Okay, let's just dive right in. We're going to take a trip to one of the most extreme places in the entire universe, the edge of a black hole. We're going to talk about the truly bizarre, kind of terrifying, and very, very real thing that happens when you just get a little too close for comfort.
So our destination looks something like this. You've got this incredible swirling vortex of superheated gas and dust, all spiraling down toward a point of no return. It's beautiful, sure. It's chaotic. And it's absolutely deadly. But what actually happens if you slip past that edge?
So that's the big question, isn't it? I mean, movies and sci-fi have all sorts of wild ideas, but physics has a surprisingly specific and, well, frankly, a pretty gruesome answer.
That's right, you heard me. The scientific term for what happens is spaghettification. And no, I'm not making that up. It's a real concept that describes an object literally being stretched and torn apart by insane gravitational forces.
So, to understand how you get turned into cosmic pasta, we first have to get our heads around the force that does the dirty work. And it's a force you actually experience every single day, just in a much, much gentler form.
Now this is the key. It is so important to get this distinction. We're not talking about how strong gravity is overall. We're talking about how fast that strength changes over a distance. That difference is what we call a tidal force.
And this is the perfect way to think about it. Here on Earth, the moon pulls just a tiny bit harder on the water closest to it than it does on the water on the far side of the planet. And that little difference is enough to create our ocean tides. Now imagine that difference, but magnified by billions. Near a black hole, the pull on your feet would be astronomically stronger than the pull on your head. And this isn't just some vague idea, you know? This is real physics. Scientists can calculate this stretching force with incredible precision using this very formula. It all depends on the black hole's mass, how far you are from it, and, well, how long the object being stretched is.
All right, so with the science sorted, let's start our first hypothetical journey. We'll start small. Well, small for a black hole. We're heading for one with about the same mass as our sun.
So picture it. You're an astronaut. You're drifting, feet first, toward this stellar mass black hole. As you get closer, that difference in gravity, that tidal force, it really starts to ramp up.
This quote I found on Reddit actually explains it perfectly. Your feet are accelerating way, way faster than your head is. Every single part of your body is being pulled at a dramatically different rate.
So what happens? The crucial point is this. Your body just can't handle it. The atomic bonds holding you together would fail. You would be stretched out into a long, thin stream of atoms, what some people have called cosmic taffy.
So just how strong are we talking here? Well, at a distance of about 100 kilometers from a sun-sized black hole, the stretching force across your body is equivalent to this number.
51,700. Times the force of gravity you feel right now. Yeah, there is no surviving that. You would be spaghettified long, long before you ever even reach the black hole's edge.
Okay, that was grim. So for our next trip, let's go bigger, a lot bigger. Let's head toward a supermassive black hole, like the monster sitting at the center of our own galaxy.
Now, your first thought is probably bigger black hole, more gravity, even more violent death, right? The spaghettification should be completely off the charts. But this is where physics gets really weird and counterintuitive.
Let's look at the numbers. At the event horizon of a supermassive black hole, the tidal force across your body isn't some ridiculously high number. It's that. An almost immeasurable fraction of 1g.
This is just mind-boggling. The tidal force is so gentle, so weak, you would feel absolutely nothing. You could float right across that event horizon without any sensation of being stretched at all. You'd be completely unharmed. So, why? It all comes down to scale. A supermassive black hole is so enormous that its event horizon is millions of kilometers away from its center. So over the tiny 2-meter length of your body, the force of gravity barely changes. The curve is just too gentle to notice.
So you can cross into a supermassive black hole safely. But let's be crystal clear. A safe entry does not mean it's a safe trip. The real danger isn't how you enter, it's the fact that you can never, ever leave.
You see, the event horizon isn't a physical wall. It's a boundary in space-time itself. It's the point where gravity becomes so strong that nothing, not even light, can escape. Once you're past it,
every possible path you can take leads in only one direction, inward.
And that inward path inevitably leads you to the singularity at the center. This is where all the mass of the black hole is crushed into a single point of infinite density. Whether you arrived as a person or as a stream of atoms, your journey ends right here where our laws of physics just stop working.
And that brings us to our final, chilling thought. For a supermassive black hole, this point of no return is completely invisible. It's undetectable. You would feel nothing, you'd see nothing change, you would just drift across an imaginary line, totally unaware that you've just made your last mistake. So how would you ever know it's too late?